Welcome to an example in which it says a manufacturer can produce 3240 cell phones when X dollars is spent on labor and Y dollars is spent on capital. The equation that relates X and Y is that. Find a formula for dy dx. Okay, so to find dy dx, we're going to need to take the derivative of both sides. Now, it might be easier to make this like 0.75 and make this 0.25, right? Three quarters of a dollar, 75 cents, one quarter, 25 cents. Either way, whatever. Okay. Let's do it. So what's the derivative? So I'm doing the derivative of sides. Well, numbers in front of functions just sit there when you take the derivative. He's just sitting there. Okay, then this guy, that 0.75 is going to come down. X to the subtract 1, it's minus 0.25. Oh, yeah, I better realize this here. This is going to be a product rule. Yeah, yeah, yeah. Okay, here, hold on. No, this is product rule. I forgot. This guy is the first function. This guy is the second. I got to do product rule, huh? Product because it's two functions multiplied. You might wonder, why did you do 6 with the first? It's just convenient. You can put it with the other one, it doesn't matter. So I'll just say the first one's 60x to the 0.75, and the second one's y to the 0.25. Those are the two functions times multiplied. So that means product rule, which means what? They take turns. So the derivative of the first one is there, times the second one, unchanged, plus the first one unchanged, 60x to the 0.75, times the second one. Whoops. The times the derivative of the second one. It's his turn, right? The derivative of y to the 0.25. What's that going to be? The 0.25 is going to come down, right? That 0.25 comes down, and then subtract 1 from the power quarter minus 1 is minus 0.75. But that's not all. I hope you know. Times y prime because of the chain rule. He's always there. And that equals 0. That's the right derivative of a constant number, which is 0. So do you see what happened right there? So again, this is two functions multiplied, 60x to the 0.75 and y to the 0.25. So I take turns, do the derivative of the 60x one first, the y doesn't change. Then it's the x one that doesn't change, and it's the y's turn. The 0.25 comes down, subtract 1. But since the inside is not a simple x, it's a y. Chain rule says multiply by y prime. Okay, so now, there we go. So now we need to solve for y prime. So to solve for y prime, I'm going to grab this whole term right here, because here's the y prime, right? I'm going to jump this guy to the other side. Okay, I'll bring this down here. So this will be 60x to the 0.75 times 0.25, y to the minus 0.75, and then the y derivative equals, and then this side goes the other side, and this term goes the other side, becomes negative. Negative 60.75 x to the minus 0.25 y to the 0.25, right? This term. Move to the other side so it's negative. Now we can solve for y prime. Just divide on both sides by the 60x to the 0.75 times 0.25 y to the minus 0.75. Boom, boom. And then 60x to the 0.75 0.25 y, what is it, to the minus 0.75. Okay, so now come on down, and y prime is now alone. These 60s cancel, um, and these negative, I can do it slower here. Let me see. Here, I'm anxious just to get her done, but I'll go slow here. So 0.75 x to the minus 0.25 y to the regular 0.25 on the bottom. Yeah, x to the 0.75. Oh, and I'll put the 0.25 out front. This 0.25. and then y to the minus 0.75. Now, the negative powers want to jump, right? This negative power guy wants to go up there. This negative power guy wants to go down there. Remember, negative powers aren't happy where they're at. They want to jump to the other side of the fraction. Then they're happy. Then they become positive. And you can just divide these on your calculator. 0.75, how many times does 25 cents go into 75 cents? 3. Okay, and then this is going to be x to the, oh, wait, my mistake. The x's end up on the bottom, don't they? X to the 0.75, and then this x comes down, and he becomes positive after he goes down. And the y's go up. This y was already up there, and the other y, this one moves up. Okay, now we're so close. What do we do with that? Well, that means we get this 3 here. These powers add. So it's y to the 1. 25 cents to 75 cents is 1.0. They add to be 1.0, and it's y to the 1. These powers add x to the 1. And that's it. 3y over x. Now, that's part 1. Minus. Oh, is it minus? Did I lose the minus sign? Um, where did the minus sign go? They said it's minus 3y over x. I did not get minus. Let's see here. Oh, right there, huh? Right here, this minus sign. I lost this bad boy. Minus, minus, sorry. Minus. There it is. I lost it. There's so much, huh? That minus sign right there, right there, and right there. They're right. I lost the minus sign. And so there. Oh, and the last step is to plug in 8116. So now they say plug in 8116 for X and Y. So put 81 there, 16 there, hit the buttons on your calculator, and you'll get what they got. And so there we go.